Download this code from codegive.com, link in the description below. Understanding and handling Java.NET. Socket exception, socket closed in Java. The Java.NET socket exception, socket closed is a common exception encountered when working with Java sockets. It indicates that the socket you're attempting to use has been closed, either intentionally or unintentionally, before you tried to perform an operation on it, like reading or writing data. This tutorial will comprehensively cover the causes of this exception, different scenarios where it occurs, and effective strategies for handling and preventing it. 1. What is a Java socket? Before diving into the exception, let's briefly recap what a Java socket is. Abstraction for network communication. A socket represents an endpoint for network communication between two machines. Think of it as a virtual telephone line. Client and server sockets. There are two main types. Server socket, server side listens for incoming connection requests from clients. Server socket.accept, creates a socket object for each incoming connection. Socket, client side or created by server socket represents an actual established connection. The client uses this to connect to the server, and the server uses the socket object returned by accept, to communicate with the client. TCP/IP protocol. Java sockets typically operate on top of the TCP/IP protocol, which provides reliable, ordered, and error-check delivery of data. 2. Causes of Java.NET. Socket exception, socket closed. The exception Java.NET. Socket exception, socket closed is thrown when you try to use a socket object that has already been closed. Here are the common reasons. Explicit closure. The most straightforward cause. The socket.close method was called explicitly on the socket object before you tried to use it. This might seem obvious, but it's crucial to ensure you're not prematurely closing the socket in your code. Server-side closure. If the server closes the connection, the client's socket object will become invalid and any attempts to read from or write to it will result in this exception. This can happen if the server encounters an error, decides to terminate the connection, example after a timeout or receiving a specific goodbye message, or is simply shut down. Client-side closure, for server. If the client closes the connection, the server's socket object, associated with that client, will become invalid and any attempts to read from or write to it will result in this exception. This can happen if the client encounters an error, decides to terminate the connection, or is simply shut down. I/O errors. Network issues or other I/O errors, example a broken network connection, firewall issues, resource exhaustion, can cause the socket to be closed unexpectedly. Timeouts. If a socket operation, like read, or write, times out, the socket might be closed by the underlying operating system or Java runtime to prevent indefinite blocking. Garbage collection, potentially while rare, if the socket object becomes eligible for garbage collection before you're finished using it, the finalizer might close the socket, leading to this exception later. Important note: this is not the primary cause. Relying on the finalizer for resource management is bad practice. Always explicitly close resources. Multi-threading issues, concurrency in multi-threaded applications. If one thread closes the socket while another thread is still attempting to use it, you'll get this exception. Proper synchronization is critical in multi-threaded socket programming. 3. Scenarios where the exception occurs, with code examples. Let's examine some common scenarios where this exception arises, along with code examples demonstrating how to reproduce and handle them. Scenario 1, Explicit closure, client side. Explanation asterisk. In this example, the client explicitly closes the socket using socket.close. Any attempt to write to the print writer, out.println, this will fail, after the socket has been closed will result in a socket exception. How to handle it asterisk. 1. Ensure proper sequencing asterisk. Make sure you don't perform I/O operations after you've intentionally closed the socket. Move the socket.close, call to the end of the code block, after all necessary communication has completed. Scenario 2, server-side closure, client receives. Explanation asterisk. In this scenario, the server explicitly closes the client socket after sending the initial response. When the client attempts to read a second response using in.readline, it will likely encounter a socket exception because the connection has been terminated by the server. How to handle it asterisk. 1. Proper communication protocol asterisk. Establish a clear communication protocol between the client and server so that both sides know when the connection should be terminated. For example, the server could send a goodbye message before closing the socket, and the client would know not to expect any further data. 2. Error handling asterisk. Use a try-catch block to gracefully handle the I/O exception that is thrown when the socket is closed by the server. This allows the client to detect the closure and respond appropriately. 3. Read returns null asterisk. Note that when the socket is closed by the other side, buffered reader.readline will return null, or similar methods, like input stream.read, might return -1. This is the standard and preferred way to detect a closed socket in most cases. Don't rely solely on catching exceptions, as they can indicate other problems besides a closed socket. Scenario 3, timeouts. Explanation asterisk. In this case, the client sets a socket timeout using socket.setSoTimeout, 5000. If the server doesn't send any data within 5 seconds, the socket.getInputStream.read call on the client will throw a socket timeout exception. After the timeout, it's good practice to close the socket since its state is now uncertain. Depending on the OS and Java version, the socket timeout exception might have already closed the socket, but explicitly closing it handles this case and avoids potential resource leaks. How to handle it asterisk. 1. Set appropriate timeouts asterisk. Choose timeout values that are reasonable for your application's expected network latency and data processing time. 2. Catch socket timeout exception asterisk. Always catch the socket timeout exception and handle it appropriately. This might involve retrying the operation, if it's safe to do so, logging the error, or closing the socket. 3. Close the socket, if necessary as mentioned. Explicitly close the socket within the catch block of socket timeout exception or in the finally block. This ensures that resources are released even if a timeout occurs. Scenario 4, multi-threading. Explanation asterisk. In this multi-threaded example, one thread, sender thread, attempts to send data through the socket, while another thread, closer thread, closes the socket after a short delay. If the sender thread tries to write data after the closer thread has closed the socket, a socket exception, socket closed, will be thrown. This demonstrates a classic race condition. How to handle it asterisk. 1. Synchronization. Locks use synchronization mechanisms, example synchronized blocks, reentrant lock, to ensure that only one thread can access the socket at a time. This prevents one thread from closing the socket while another thread is still using it. 2. Atomic operations asterisk. If possible, use atomic operations, example atomic boolean, to track if the socket is open, to manage the socket's state in a thread-safe manner. 3. Thread-safe classes asterisk. Consider using thread-safe classes, like those in Java. Utility concurrent, for handling socket communication. These classes provide built-in synchronization and can simplify multi-threaded socket programming. For careful design * review your application's design to minimize the need for multiple threads to access the same socket. Often, you can delegate socket management to a single thread or use thread pools to manage communication tasks. Here's an example of using a reentrant lock *. Key improvements with the lock *. Mutual exclusion *. The socket lock ensures that only one thread can access the socket at a time. This prevents the closer thread from closing the socket while the sender thread is writing to it. Visibility *. The socket is closed flag is protected by the lock, so changes made to it in one thread are visible to other threads. Try-finally blocks *. The try-finally blocks guarantee that the lock is always released, even if exceptions occur. This is crucial to prevent deadlocks. 4. Best practices for handling socket exception, socket closed. Here's a summary of the best practices to help you effectively handle and prevent java.net socket exception, socket closed exceptions. Explicitly close sockets. Always explicitly close your sockets using socket.close, and server socket.close, for server sockets, when you're finished with them. Wrap socket operations in a try-finally block or use try with resources to ensure that the socket is closed even if exceptions occur. Proper communication protocol. Define a clear communication protocol between the client and server. This includes specifying how connections are established, how data is exchanged, and how connections are terminated. A robust protocol reduces the likelihood of unexpected socket closures. Consider using a state machine to track the connection state on both the client and server. Error handling. Use try-catch blocks to gracefully handle potential I/O exceptions that might occur during socket operations. Log the exceptions to help diagnose problems. Timeout mechanisms. Set appropriate timeouts for socket operations using socket.setSo timeout. This prevents your application from hanging indefinitely if a connection is lost or data is not received within a reasonable time. Check socket state. Before performing I/O operations on a socket, check if the socket is still open using socket.isClosed. Although this isn't foolproof, another thread could close it right after you check. It can help prevent some exceptions. Multi-threading considerations. If you're using sockets in a multi-threaded environment, use proper synchronization mechanisms, locks, atomic variables, to protect socket access and prevent race conditions. Carefully design your application to minimize the need for multiple threads to access the same socket. Robust server handling. On the server side, handle client disconnect ions gracefully. If a client closes the connection, the server should clean up resources and avoid trying to write to the closed socket. Connection pooling. For applications that frequently establish and close connections, consider using a connection pool. A connection pool manages a set of reusable connections, reducing the overhead of creating new sockets for each request. However, make sure your connection pool implementation handles closed sockets correctly by removing them from the pool. Check for null reads. After reading from the socket, especially with buffered reader.readline, or input stream.read, check if the return value is null, or -1 for input stream.read. A null return value typically indicates that the other side has closed the connection. 5. Example of robust socket handling, client and server. Here's a complete example demonstrating how to handle socket exceptions and ensure proper socket closure on both the client and server. Key features of the robust example. Try with resources. Uses try with resources blocks to automatically close sockets and streams. This ensures that resources are always released, even if exceptions occur. Null check the client and server check for null return values from buffered reader.read line, to detect when the other side has closed the connection. Exception handling try-catch blocks are used to handle potential I/O exceptions, including socket exception. Loop for multiple clients, the server is set up in an infinite loop, while true, to handle multiple client connections. Each connection is handled in a separate try block. Server initiated closure, optional. The server can close the connection based on the content of the message received from the client, example if the message contains close. In summary, understanding the reasons behind java.net socket exception, socket closed, implementing appropriate error handling, and following best practices for socket management are crucial for building robust and reliable network applications in Java. By implementing the techniques described in this tutorial, you can greatly reduce the likelihood of encountering this exception and improve the overall stability of your socket-based applications. Remember to pay close attention to proper socket closure, communication protocols, timeout mechanisms, and thread synchronization to ensure a smooth and reliable communication process between your client and server.